Bismillahirrahmanirrahim. In this session, we will discuss the kinetic particle model of matters from the book of Tom Deacon and Heather Kennett, 2021, published by Orders Education for O level and IGCSE students. In this session, we will learn about the three states of matter: solid, liquid, and gases. The particles in each state of matters are ordered differently, and this leads to each state having different properties. So each solid, liquid, and gases have a different property. Solids have a high level of internal orders, so they are very close, and liquid has a less internal orders, slightly different, less than this solid. But in gas, the particles have no orders and move about randomly. So this is in a solid has a high level of internal orders, a middle level of internal order, and no order at all, and particles moves very rapidly or randomly. The state of material can be altered by heating or cooling. So solid, after heating and cooling, liquid in cooling, reshape different states. In a solid, the bonds between the particles break down on heating. When a solid is heated, its bonds break down, and as a result, it's melt into a liquid. So on heating, the bonds break down and the solid transform into a liquid. For example, ice melts into water. This is a heating process. Boiling a liquid produce a gas. On boiling a liquid, it transforms into a vapors or a gas with a well separated particle. Water turns into steam. So the three states of matter can be represented in a particle diagram. Tiny particles, that is atoms, molecules, ions, and electrons, can be seen by scientific eyes, that is electron microscope can be used to see these atoms, molecules, ions, and electrons. These tiny particles are always in a continuous motion. These tiny particles, atoms, molecules, ions, and electrons, are in continuous motion. They are always in continuous motion in a certain temperature. So the solid have a definite shape and volume. Solid always have a definite shape and volume and are not easily compressed. It is incompressible. So the liquid have a definite volume, but their shape depends on the container they are kept in. So its shape depends on the container where this state of matter is placed. So liquid have a definite volume but no shape. It doesn't have its own shape, but it takes the shape of the container where it is placed. When a liquid is cooled sufficiently, solidification occurs and it returns to the solid state. When a liquid is cooled, it solidifies and it returns to the solid state. The density of a material in its solid state is usually higher than it is in its liquid state. The solid states have a high density. Usually the solid states have high density and then the liquid state. When a liquid is heated, the particles can escape from its surface by a process called evaporation. At different temperatures, on slight heating or gradual heating, the surface molecules or particles escape from the surface. This process is called evaporation. When sufficient energy supplied to the liquid, that is a boiling occurs and the liquid turns into a gas. So the difference is evaporation occurs at every temperature, but this boiling occurs at the boiling point. Gases have no definite shapes and volumes, and these depends on the dimension of the container where it contains. So when a liquid is cooled sufficiently, when a gas is cooled sufficiently, it returns to the liquid state in a process known as condensation. When a gas is cooled sufficiently, it returns to the liquid state through a condensation process. That process is called condensation. The drops of waters are formed when steam condenses on a cold window pane, for example. This is a test yourself on page 87 from the Tom Decken and Heather Kennett book of O-level physics. Here we have first question: using what you know about the compressibility or squeezability of the different states of matter, explain why. Air is used to inflate tires because gases are more easily compressed. So air is used to inflate tires. So when we inject air inside the tire, it can be more masses can be inserted into the tire because this gas is compressible. Then the solid or liquid and expands more when they are heated. So when it is heated, it expands. Steel is used to make railway lines because it's a hard shape, it's a definite shape. Steel bars are formed of metals that is solid, which have a definite shape and volume and are not easily compressed. That's why steel is used to make railway lines. It's a hard material. Identify the process in which the solid turns into a liquid. Solid turns into a liquid, that is called melting. A liquid turns into a gas, that is a boiling. A liquid turns into a solid liquid, this is solidification. And a gas turns into a liquid, that is condensation. So this is very, very important. These are the process: melting process, boiling, and solidification and condensation. Particle models, learning outcomes. The properties of solid, liquid, and gases can be related to the arrangement, separation, and motion of the particles. Arrangement, separation, and motion of the particles. In a gas, the particles are well separated and constant random motion, producing pressure on the container by their collision with its surface. In solid, the particles are closely arranged and firmly bound together with a regular pattern in crystal. In a liquid, the particles are further apart. The only local ordering between the particles that have more freedom of movement than those in the solid. So the forces between the attraction and repulsions exist. So the particle model can be explained existence of solid, liquid, and gaseous state. Teach yourself on page 90. Here we have explained the structure of solid, liquid, and gases. Solids have close together. The particles are close together, and attraction and repulsion forces between neighboring molecules balance. So this is the arrangement, and each particles vibrate. This particle or this particle vibrates about a fixed position, about its own fixed position, and the particles in a solid can be arranged in a regular repeating pattern like those formed by a crystalline substance. Figure 2.12a represents the arrangement of a particle in a solid. So we can imagine a spring representing the electric forces between the particle that hold them together. So this particle that vibrates here and there like this. So this spring structure is using to show that it can vibrate in a different directions. So in a liquid state, the the particles are slightly further apart than a solid, but still close enough together, have a definite volume. As a result, as well as vibrating, they can at the same time move rapidly over the short distance, slipping past each other in all directions. So this is the liquid arrangements. In a model represents this kind of arrangement. This can be analogous analogy. This analogy can be used. This is a marble in a tiny. Okay, if we tilt this, it concentrate on this side. So it overlap. Some of this passes over and then comes to this point. And in the liquid, the process. The force between the particles are less than in a solid. So the distance between the particle is greater than the solid. And in a gases, the particles in a gases are much further apart than in a solid and liquid. So gases are much less dense and can be squeezed into a smaller space. So this can be squeezed. So here we have this particles. The balls are there in a container with the lid covered, and as we increase the temperature, adding more balls by bearing in each pumping, and we are pumping it. So as a result, this will strike with this container's surface. So this is the experimental setup to show or to simulate the gaseous particles. Question number 4. Explain what is meant by the term absolute zero. So when the temperature is reduced of any matter, state of matter, so if a temperature is reduced, the average kinetic energy of the particle reduces. Temperature reduces, the average kinetic energy of the particle will reduce, and eventually the temperature is reached where the particle motion ceases. No vibration. The particle motion becomes cease, and the kinetic energy of the particle is zero. We call this, and the kinetic energy of the particle is zero. We call this temperature absolute zero, and it occurs at minus 273 Celsius. So at this temperature, the vibration of the particles becomes cease, and there will be no motion, so everything will be dead. So that's a theoretical temperature, and where these particles become cease. And the variation in gas and pressure and volume, it will be discussed in the next